Hey everybody, this is David with IsoHorns, and today I want to continue the conversation about side lobes because our competitor, RF Elements, has been misleading WISPs for more than a decade, claiming that the reason why their horn antennas are special and perform well in noisy environments is because they supposedly have no side lobes. And it's this no side lobes that makes it so that they perform well in noise and saves spectrum and allows for frequency reuse. But it's not. Spoiler, the reason why horn antennas perform particularly well in noise and also allow for frequency reuse is because of the narrow beam widths. So if you have a sector antenna that's providing service to a 90-degree coverage area, then it's picking up noise from that entire 90-degree coverage area. And if you divide that into three 30-degree sectors, then each sector is only going to pick up noise from 1/3 of that sector. Each 30-degree sector only picks up about 1/3 of the noise. And you can use A-B channel planning with channel A here, channel B here, and channel A here again. And then you can continue that. And in a dense environment with lots of noise, you can cut through the noise, focus the signal where it needs to be, while also picking up less noise from the sector by using more narrow sectors. And that's the secret of horn antennas. But RF Elements didn't want WISP to know that. They wanted WISP to believe that their horn antennas were special, and it was the special zero side lobes of RF Elements that allowed them to perform well in noise, which is simply not true. Let's listen to this.
Exactly. So, you look at the spec sheets and you're like, okay, let's do actual comparisons. You'll see ours very clean cut on the main lobe, very high beam efficiency. No side lobes and back lobes. That's, one of our big points that we always make all the time. But you look at some of these others and you're like, man, for a horn, this has got some wings on it. So it's got some little side lobes, it's got some back lobes, which you really shouldn't expect when you're looking at something like that. So that's important.
So this is this is painful for me to watch. They're having a good time with it, but it's painful for me because IsoHorns. This is IsoHorns data sheet, and you can see that our horn antenna shows prominent side lobes, and there's many WISPs that are going to consider IsoHorns. They're going to look at the data sheet. They're going to see these prominent side lobes, and then they're going to discount IsoHorns, thinking that the side lobes mean that this is not going to perform well in noisy environments. When what's actually happening here is IsoHorns is being honest. We are honestly representing our side lobes. And honestly representing our side lobes is important. It goes back to that frequency reuse. So if you're going to reuse frequency, then you need to make sure that you're not stepping on large side lobes. So you can see with our side lobes how you can reuse frequency with our horn antennas. Whereas with RF Elements, they omit those side lobes. So here's their antenna pattern. This is the same exact type of product. So this is a 30-degree asymmetrical horn antenna, just like IsoHorns. And they don't show the side lobes. They don't provide as much detail in their antenna pattern. Their antenna pattern appears to be hand-drawn, whereas IsoHorns is obviously computer-generated. It is computer-generated. Can't speak for theirs, but ours is computer-generated. And they assert that the vertical and the horizontal polarities are the same. So they say the V and H port pattern azimuth for 5.6. They don't show separate vertical and horizontal, and they only show one frequency. So this low-detailed antenna pattern isn't very useful because it doesn't show you what the antenna pattern, what the beam looks like at various frequencies. It doesn't disclose the side lobes, so you can't do proper channel planning and work around the side lobes. and it doesn't show you the different polarities. So IsoHorns gives you everything you need to make informed decisions about our antennas and how to use them. RF Elements does not, for the purpose of marketing. So when WISPs look at this, they think that this is going to perform better than this because of that decade of misleading marketing, like what we just saw from RF Elements. In actuality, this antenna outperforms this antenna every single time. We've never seen a situation where an RF Elements antenna in a head-to-head comparison outperforms an IsoHorns. IsoHorns outperforms it in terms of um, download speeds for subscribers. We've seen anywhere from 10 to 50% improvement in download speeds for subscribers, just replacing one side of the link. And here's an example of a WISP doing a head-to-head comparison with these two antennas. So up here, we've got the RF Elements 30-degree asymmetrical horn. Down here, we have the IsoHorns 30-degree asymmetrical horn. And the WISP moved the radio from the RF Elements to the IsoHorns. Didn't lose a single connected station. All the stations stayed connected, but this Ubiquiti Rocket Prism AC Gen 2 saw significantly better performance on the IsoHorns antenna, and here the WISP is going to talk about that.
In the two asymmetrical horns, the IsoHorn was noticeably better, like objectively better on numbers. And we have the screenshots that we're going to put up, and we'll be able to see.
And that was, you said that the modulation rates with the IsoHorns, nothing was below 220?
Yeah, nothing. So after it was able to sit and everything modulated up, there was nothing below 220.
Okay. And then with the RFE asymmetrical,
we got one down at 165.
So what he's saying there is that the IsoHorns, all of the stations had modulation rates that were better than 220 megabits per second as per the Access Points list of stations. And with RF Elements, there were some stations that were well below 200. And on further inspection, IsoHorns, what IsoHorns is doing is we have even coverage. And so all of our stations had strong signal, whereas with RF Elements, the stations towards the center of the beam had good modulation rates, but the stations towards the edges of the beam did not. And that indicates that the antenna may have more gain. So it may have more focused signal towards the center. But more likely, what's happening is that there's a chain mismatch where, going back to here, it says the vertical and the horizontal pattern is represented by this, whereas with IsoHorns, we show that the vertical and the horizontal patterns are different. And so when you're towards the center of the beam, these patterns are more similar. But as you get towards the edges, there's some divergence. This is a wider beam than this. And so there's a little bit of a mismatch as you go towards the edges. But according to the test, RF Elements has that more prominent, meaning their claim that these are the same is not true. And they don't just misrepresent it on their data sheets, they also misrepresent it plainly in the marketing. He says, we show the beam patterns for both polarizations. No, they don't. This is a lie.
If they manage to show you the beam patterns on both polarizations, you'll see that they're not equal. And it's
so we show the beam patterns for both polarizations, and he's right. They're not equal, but we don't claim that they're equal. So we're not lying about the capability of our product. And in real world environments, IsoHorns performs better, particularly on the edges of the beam, where the polarization mismatch will cause chain mismatches. Okay, so there's another way that RF elements is plainly lying when they say that they have 0 side lobes, and it's doesn't require testing in the field. They just contradict themselves with their own tools. So here they have the elevation beam pattern. This is when you take a 30-degree horn and you switch it 90 degrees, then it becomes a 20-degree horn. And so they show you what they call the elevation pattern. IsoHorns can do the same thing. When you order a 30-degree horn from IsoHorns, simply ask for the L bracket, and we will include it in the box. And then you can also use our 30-degree horn as a 20-degree horn on the azimuth. So that gives you an even more narrow beam width, which is useful, again, for limiting the amount of noise that you pick up from the sector and for frequency reuse. So here is RF Elements Link Calculator 2.0. And you can do this as well, but basically if you take a point to multipoint and then move the access point into the flatlands and move the station into the flatlands, make sure it's point to multipoint, and then do the asymmetrical point to point, point to multipoint, the asymmetrical horn 20-degree. There it is. I don't know what I was doing wrong. I was double clicking when I shouldn't have been. And then you've got to add the 5 and the 4-0. But when you do this with RF Element's own tool,
a few moments later,
so you can see that this 30-degree asymmetrical horn on its elevation pattern has 4 very prominent side lobes. So you've got this one here, this one here, this one here, this one here. I suspect there's more that simply don't show up. But this is just shows that their representation that their horn has 0 side lobes is blatantly false. And those side lobes should be represented at least on the elevation pattern, and they're not. Thanks for watching.